In this video, I need you to grade your free body or your free response question. Then I also want you to just watch the video and see how I explain it, and then come back in if you still have questions. So the first one, it says draw the free body diagram on Tex as he's spinning in the problem. One big thing to think about is it says he is glued to the wall. Right? So we know gravity has to be there, mg. Then it says he's glued to the wall, so his acceleration in the y is 0. He's not going up or down. Then I have to have an upward force. That's going to be force of friction. Because here is, here's the wall, and the force is going to be parallel to that. So we know the force of friction is parallel to the surface. The next one, we can see it's changing direction, so I have an acceleration to the center. So I also have to have a force. Now, what is that force? Well, it's again the surface. Then we know our other surface force is the force normal. Okay. To grade this, we see over here on the right, you get 1 point for each correct force, so that would be 3 points. 1 for each of those, right direction and also correctly labeled, and then minus 1 point for each incorrect force. If you had any more forces on that, you would get a minus 1 for each of those. Minimum score is a 0 though. The next problem says, as the rotational rate of the ride increases, what happens to the normal force? So rotational rate is how fast the velocity is. So you got 1 point for saying the normal force increased. So Fn went up. And then you get 1 point for an explanation. So you could say because, and if you had derived out your net force statement, you would have Fn equals mv squared over r. So here I can see velocity increases, normal force increases, if the other two are kept the same. Okay? You can't just circle what I have here, you have to explain, so I'll write a sentence or so with that. Another way to think about it, right, is as you go faster, you need to change direction more, and what causes the object to change direction? The normal force. So with that, you could say more velocity needs more of a force to keep it into the circle. The next problem, you get 1 point for having it be an upward parabola, something like this, right? And that's it. Now, why is it like that? Well, I can see the relationship between Fn and velocity, right? So I have Fn on my y-axis, v alone on my x-axis. This would be like y equals x. But I can see it is squared. So y equals x squared. You know, the shape of that is a parabola. Or the other thing you could have done is plugged in numbers. So if I did this one, I would say, well, Fn equals mv squared over r. And I can see here, if I plugged in 0.25 for v, I would square that. So then this side has to be 0.25 squared. 0.25 squared is going to be less than 0.25. So somewhere around here, you could plug the number and see what that actually is. In part D, why doesn't Tex slide down the wall? Well, back to our free body diagram, we saw in this problem that we had force of friction. So upward we have the force of friction. Downward we have the force of friction, force of gravity. So if he doesn't slide down, then these two have to equal each other. So that was 1 point right here. You'd have to say that, okay? That force of friction equals the force of gravity. Next from there, well, how can we see that these are equal? Right? Because he would have fallen out at the beginning, but he doesn't later on. Well, I know what's happening when he speeds up, then I know the normal force increases. Right? Then I can see, well, if normal force increases, we know force of friction increases because force of friction equals mu Fn. Fn goes up, force of friction goes up, and that's going to keep him from falling down. Okay. In this equation, we need to find the maximum period such that the ride can offer safely. Okay. Maximum period, okay, it's going to take me the longest time, so essentially this is also the slowest velocity. You had to pick some equations. Well, if I'm trying to find period, I have to have an equation that has period in it. So this one has to be there. Okay. Next, well, how do we start all forces problems? I have to have this free ride diagram, the net force statement. Then we saw that what happens as you speed up or slow down, that affects the force of friction. Now, this is static friction because it doesn't actually move. So this is force of friction static equals mu Fn. And then how do I even get to velocity? Well, for my net force statement, I need acceleration equals v squared over r. As you can see over here on the right side, you get 0.5 for each correct equation that you have circled, and then minus 0.5 points for each incorrect equation. On free response, I saw some of you just left this blank, but you can never just leave anything blank. At least just close your eyes, pick a couple of them. Okay? But hopefully you saw the strategy of, okay, why are these have to be here? All right, so in this problem, now we have to develop that equation. Well, first off, we had our free body diagram, okay, so we could have looked at that. Now, you don't have to get any points for redrawing it, but I like to be able to see it. Right, force of friction up, force normal to the center, and mg. Well, we know at the maximum period, essentially when you go slow, okay, you're almost going to fall, but I don't actually fall. So then I could look at in my y direction that I could say F net in the x equals may. Let's look at y. There's no really x direction. So I would say this is force of friction minus mg equals 0. So I would have gotten 1 point, or excuse me, half of a point right here for using the equation that I talked about up above. Then from there, I could say, well, force of friction has to equal mg. Okay. Now from here, I can see what is affected so this thing doesn't fall down. Well, that's affecting force of friction. Okay. But we know what affects force of friction is force normal. So in this one, then I could look at F net centripetally equals MAC. This is just Fn equals MAC, but we know we need to get to period, so this is where I would do mv squared over r. So if you had this one, you would have gotten 1.5 points for plugging in an equation for Fn. Sorry, just 0.5. But then you also would have got another point here, or 0.5 points, for saying AC equals v squared over r. So I've already used 1, 2, 3 of the equations above, so now I can go a little bit farther than this. I know I need to get these two equations equal to each other. So from here, I know I'd go the next step, and I would say, well, force of friction, that has to equal, if I rewrote this one here, that force of friction equals mu Fn. Then I could plug in this one, so I got 0.5 points for writing this. And this equals, we said Fn equals mv squared over r. So I'll do mu times mv squared over r, and that equals mg. From here, now I could cancel out the mass, and then I plug in my last equation, which is going to be v. So I know mu times v, which is 2 pi r, 2 pi r over the period, and that all has to be squared. And then I also divide by r, so I can say that's times 1 over r, and that equals g. Doing a little bit of algebra there. I also got another 0.5 points right there for subbing in my new equation that I said into v. So then lastly, I can just do the algebra, and you would get 1.5 points, for the final answer, which is going to be 2 pi times the square root of mu r over g. So I said we had half of a point for this. We gave a full point because this involved two equations, so then we're up to 1.5 points. Here we are, so here with this equation here got us another one. There's 2 points. Here we had 2.5, and then with this last final answer, you had 3 total points on that one. If you had any, if you don't have those equations written down somewhere, you wouldn't get the points. Again, the last one you got half a point for. And our last point, we have your explanations. Is it safe to operate? Essentially, you get 1 point for saying no, this wouldn't be safe because the object would fall. Right? Then you have to have an explanation for why the object would fall. Well, why the object would fall, right, is because you have a larger period. Right? The previous problem, we had the maximum period for it to still stay at rest. So if I went greater than the maximum, again, if I'm going greater than the maximum, it takes more time. So if it takes more time, then the Fn will become too small, and I will have too little of friction. One way you could look at it is also say for this explanation, Fn equals mv squared over r. If r goes up, then Fn becomes less if you stay at the same velocity. Right? If Fn becomes less, then the object would fall. So hopefully look over that, come up with some questions that you have, kind of see where your grade's at, and we'll talk about that next time in class.